Okay, going to work 8-2 now. Wait a minute. Yeah, 8-2. And yes. So for 8-2, we have 11, 13, 17 through 23 odd, 27, 29, 35, 39, 41, 45. Sorry to make you sit here and listen to me do this. 45, 47, and 53. All right. Find the exact value of each expression. So tangent of arc cosine of negative root 3 over 2. Tangent of arc cosine of negative root 3 over 2. Okay, so these are not the same types of functions. In other words, we don't have tangent with arctangent. We don't have cosine with arccosine. So this is the one where you look at what's in here and you ask yourself, what is this? Well, that should return to me an angle, right? The inverse cosine should spit back an angle. So I'm going to call that angle theta. And therefore, if I just look at this, this is really just tangent theta, tangent theta. I need to know what tangent theta is. Then I come over here and I write down, well, theta is arc cosine of negative root 3 over 2. And that is just because I called this theta. I chose to do that. Now, from here, as long as this is in the domain of the arc cosine, then I should be able to determine what the angle is that corresponds to this. Better yet, I could just take cosine on both sides. Okay. And it should just spit out, with the cancellation property, negative root 3 over 2. So long as this is in the domain, which it is, because this number has to be between negative 1 and 1. So it is. So this is just going to give me cosine of theta is equal to negative root 3 over 2. And now from this, I can try and draw a reference triangle. Now, the reference triangle is going to be a little bit weird because one of these is negative. So let's do this. Let's draw a triangle centered at the origin, like this. And we know that cosine is the adjacent over the hypotenuse. So the adjacent side should be negative and the hypotenuse always has to be positive. So that means I should move over by negative root 3 over 2, okay? I'm sorry, negative root 3. This is negative root 3. And then this should be 2. And my theta, of course, you could look at the theta as being here if you want. So cosine of theta, according to this picture, would be negative root 3 over 2. Now we need to figure out what this side is. Now this side, by the Pythagorean, is just going to be this side squared, well, so first square root. So 2 squared minus because we're trying to solve for one of the shorter legs, minus the negative root 3 squared. So this should be square root of 4 minus 3, because when you square that, you just get 3, and this should be 1. So this side should be 1, and now we want to know what tangent is. So tangent is going to be the opposite over the adjacent, so it should be this over this. So we should just have 1 over negative root 3, or negative 1 over root 3. Either way. The book rationalizes. They multiply top and bottom by root 3. I'm not going to do that. I also want to point out that, let me point this out. You could have drawn your triangle this way. And this still would have given you negative root 3, and this could have still been 2. The problem is if you're dealing with the arc cosine, you can't be down here. You can only be in the first and second quadrants. So that's why your triangle has to be over there. All right, that was a good problem to start. Secant of arc cosine of 1/2. Secant of arc cosine of -1/2 or of just 1/2. Okay, so now at this point we're going to do the same thing. We're going to call this theta in here because that's an angle. Theta must be equal to arc cosine of 1/2. And then you could take cosine of both sides. Cosine theta equals 1/2. That's valid as long as that's between -1 and 1, which it is. And remember over here, what I really want is secant theta. That's what I'm looking for. So from here, I could just get the answer right now. I don't even have to draw a triangle. Because if cosine theta is 1/2, secant theta is the reciprocal. So it just should be 2. But I can draw my triangle. This should be 2. This should be 1, adjacent over hypotenuse. Solving for this, well, we don't need to solve for this. Because, again, secant is 2 over 1 instead of 1 over 2 for cosine. So this is just 2. That's pretty straightforward, I think. How about 17? Sine of arctangent of -1. Is it 17 now? Yeah. 17. Sine of arctangent of 1. Sine of arctangent of 1. Arctangent of 1 is an angle. So my angle should be this. And when it comes to the arctangent function, we can plug in any number into this, and it's valid. So I'm going to take tangent on both sides. Tangent of that's just going to give you 1. And I can create a reference triangle. And tangent is opposite over adjacent, so I need to have 1. So 1 over 1 would work. And that makes this side root 1 squared plus 1 squared. So this is just root 2. And I want to know what sine of theta is. Sine is opposite over hypotenuse. This should be 1 over root 2, which I'm sure the book is going to rationalize. They're going to make that root 2 over 2. Okay, number 19. Secant of sine inverse of -1/2. Secant of sine inverse of -1/2. This is number 19. All right, same game. This is an angle, theta. So theta equals arc sine of 1/2. And then sine on both sides. It's valid because that's between -1 and 1. Draw a reference triangle. 1 and 2 here, opposite over hypotenuse. This side then would have to be root 3. This squared minus this squared, take the square root. And I want to know what secant is. Secant of theta should be hypotenuse over adjacent. So 2 over root 3. The book will rationalize. They'll put 2 root 3 over 3, but that's acceptable. That's number 13. 19, I mean. 21, cosine inverse of sine of 5 pi over 4. Cosine inverse of sine of 5 pi over 4. Okay, this one's a little tricky. 21. All right. This does not spit out an angle. It spits out a number. Sine of an angle gives me a number. So what I'm going to do is I'm just going to figure out what that is real quick. 5 pi over 4 is right here. So there's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. There's 5 pi over 4. Sine of that angle is the y-coordinate. The y-coordinate here is negative root 2 over 2. So what this is really saying is what's the arc cosine of negative root 2 over 2. So now we completely forget this picture and we just start again. So draw a unit circle and we're asking ourselves, where is the x-coordinate, at what angle is the x-coordinate negative root 2 over 2? But since it's arc cosine, we cannot look down here. So where is the x-coordinate negative root 2 over 2? And that happens right here, because that's negative root 2 over 2. Root 2 over 2. The x-coordinate is negative root 2 over 2. This angle is 1, 2, that's 3 pi over 4. So the answer to that is 3 pi over 4. 23, arc sine of cosine of negative 7 pi over 6. Forgot. 23. Arc sine of cosine of negative 7 pi over 6. Did I just mess that up? No. All right. So same story. Cosine of negative 7 pi over 6 is not an angle. That's just a number. So I need to figure out where negative 7 pi over 6 is. Here's negative pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Negative 7 pi over 6 is right there. And I want cosine of that, so I would like the x-coordinate here. The x-coordinate here is negative root 3 over 2. So this is really just arc sine of negative root 3 over 2. Now at this point, I start over. I'm dealing with arc sine, which means I can't look over here. And I need to figure out where the y-coordinate is negative root 3 over 2, because it's arc sine. I'm looking at y-coordinate now. And I can only be here and here. And that is going to happen right there. That's 1/2 negative root 3 over 2. So the y-coordinate is negative root 3 over 2. That angle, remember you have to go backwards, is negative pi over 3, negative 60 degrees. (27) Secant of arctangent of 1/2. Secant of arctangent of negative 1/2. Yeah. Okay, for this one, be careful. Inside here, this is an angle. Okay, so theta must equal arctangent of negative 1/2. Now, arctangent is valid for any value here. So I should be able to use a cancellation and take tangent on both sides. And I should get negative 1/2. Now, this is a little bit tricky because you have to draw a triangle, okay? And this right here should be your opposite over your adjacent. So the question is this negative 1 over 2 or is this 1 over negative 2, right? Well, remember, if you are using arctangent, all right, the angle it's got to spit out, right, this angle theta, must be between negative pi over 2 and pi over 2. So remember, this is the x-coordinate divided by y. This is the, sorry, I did that backwards. This is the y-coordinate divided by x, y-coordinate divided by x. So if we're in the first quadrant, both the y and the x are both positive, so it can't be in the first quadrant. If we're in the second quadrant, then the y-coordinate's negative, the x is positive, so it's not this one. So I'm going to draw a little triangle here. My y-coordinate's negative 1, my x is positive 2. So imagine drawing a circle, not a circle, a triangle that went like this. Okay, so this is 2, this is negative 1. So we could get the hypotenuse here. The hypotenuse should be this squared plus this squared, so this should be root 5. This is our angle theta. And now if we want to know what secant theta is, it's the hypotenuse over the adjacent. So it should be this over this. Remember, secant theta is what we wanted here. I didn't write that down. So this should be the hypotenuse, root 5, over 2. That's a little tricky. All right, number 29, cotangent of arcsine of negative root 2 over 3. cotangent of arc sine of negative root 2 over 3. All right, again, the inside of this returns an angle, so we really want cotangent of that angle. So let's go try and figure out what we can about that angle. I know that that angle has to be arc sine of negative 2 over root 3. That is not one of our common angles, or common numbers on the unit circle. It looks like it, but it's not. So let's try and draw a little triangle, but we got to figure out what quadrant we're in. So let's do this. If we're dealing with arc sine, we can't be over here. And I need that when I take sine on both sides, that sine is negative root 2 over 3. So that means sine is my y-coordinate divided by my hypotenuse, or my, I can say that, over the hypotenuse, that's fine. So, or opposite side. So my y has to be negative, because the hypotenuse can never be negative. So I know that I'm going to be down here, my y-coordinate. So let me draw a triangle. My y-coordinate is negative root 2. My hypotenuse is 3. So it's kind of like that triangle right there. Sine would be this over this. So that matches up. I've satisfied that I'm not over here. And now I need cotangent. Cotangent should be adjacent over opposite. So I need this side. This side will be square root of this squared minus this squared, which is 2. So this should be root 7. So if I take root 7 and divide it by negative root 2, that should be cotangent. Root 7 divided by negative root 2. You could probably just write this as negative, put them both together, negative root 7 over 2. Number 29, this is a weird one. Yeah, they rationalized. They actually take this and they multiply top and bottom by root 2. But same answer, so. All right. 35, arc sine of cosine of 3 pi over 4. All right, this in here returns a number, not an angle. So cosine of 3 pi over 4 is the x-coordinate at 3 pi over 4. 3 pi over 4 is a common angle. So the x-coordinate here is negative root 2 over 2. So this should be arc sine of negative root 2 over 2. And now we start over with the new circle. And we say, all right, we're doing an arc sine problem, so I can't look over here. Arc sine means I need to figure out the angle where the y-coordinate is negative root 2 over 2, and that's going to be down here, because the y-coordinate here is negative root 2 over 2. And that is negative 45 degrees, or negative pi over 4. So that's it. All right, 39, find the exact value. Cosecant inverse of negative 1. 39. All right, cosecant inverse. Man, this thing is leaving all sorts of marks. Oh, this is like a filthy rag. All right, cosecant inverse of negative 1. So remember, for cosecant, let me draw this picture. Cosecant of x, and then the inverse goes back, cosecant inverse of x. So over here, the domain of cosecant, the way we cut it in order to make this work was to go from, let me see, this is a good example of how I don't have all these memorized. So cosecant is reciprocal of sine. So I graph sine. Here's my verticals. And what we do is we cut here. All right, so there like that, and then we do this side. Oops. It's like this. Okay, so cosecant, we cut it at negative pi over 2 and pi over 2. We can include those endpoints. So it was negative pi over 2, but we have to stop at 0 because 0 is a vertical asymptote. 0 union 0 to pi over 2. So that was the domain restriction on cosecant in order to define an inverse. And then what comes out of this was negative infinity to negative 1 union 1 to infinity. Okay, so that's the output, the red output here, the y values. So now what we're saying is cosecant inverse of negative 1 means, can we do it? Can we go from here to here with negative 1? Yes, negative 1 is included. And then you're just really saying, where does this happen, right? Trying to see if there's something else I can do. I mean, it's negative pi over 2. You can just look at the picture. Negative pi over 2, you're at negative 1. Yeah, I think that's what we're going to do. We're going to say, this is saying at what angle, okay, that when you plug that angle into cosecant, do you get negative 1? And you can see it here. Okay, let me do that. I'm going to write it this way. This is really saying cosecant of what angle is equal to negative 1. That's the way I did it in class. This is saying this. What angle gives you that? And you're restricted between negative pi over 2 and pi over 2, but we can't be at 0 either. And then I said this is 1 over sine theta equals negative 1. Multiply both sides by sine theta, then divide by negative 1. So negative 1 equals sine theta. So you're really asking yourself, where on the unit circle is the y-coordinate negative 1? And that's going to happen here. That's at negative pi over 2. So 2 ways to do it. Just look at the cosecant function or do this algebra to get to the same result. All right, how about 41? Secant inverse of 2 root 3 over 3. Secant inverse of 2 root 3 over 3. So this is really saying, where is secant of theta equal to 2 root 3 over 3? Now the restriction we have for secant inverse, we did it in class, we did it very similar to this, but it was between 0 and pi, and then there was a problem at pi over 2. But this is a, I'm not going to draw the picture, should I? I'll do it. Okay, so the way we got this is we said, all right, we're going to go and graph cosine, vertical asymptotes, cosecant, secant looks like this, and then it goes like that, but we cut it, here's pi, we cut it right here from 0 to pi, and we get the whole range of the secant function. Okay, but we do have a problem at pi over 2. So that's where, when we go from here to here, this one went from negative infinity to negative 1, 1 to infinity union, right? That's what gets spit back. Here it's from 0 to pi, but take out pi over 2. So 0 to pi over 2, union pi over 2 to pi. We did it in class, but that's the basic idea here. So this number we're plugging in right here, 2 root 3 over 3, needs to live in here, and it does, all right? That number is bigger than 1, so we're good to go here. So I can write this next line. Now, this is just saying 1 over cosine theta, that's what secant is equal to 2 root 3 over 3. So I'm going to multiply both sides by cosine and multiply both sides by 3. So the cosine goes away here, the 3 goes away here. We get 3 equals 2 root 3 cosine theta. Now I'm going to divide both sides by 2 root 3. And we get 3 over 2 root 3 equals cosine theta. And that is not an obvious angle, but if you do a little bit of work to this, you'll see it. So times root 3, rationalize this one, because if not, you won't see it. If we do top and bottom by root 3, then on the top, you get 3 root 3, and on the bottom, you get root 3 times root 3 is 3 times 2 is 6. So you get cosine theta. Did I mess something up here? 2 root 3, 3. Multiply. Oh, wait, hold on. Hold on. No? Multiply 3, divide by, okay. So you get something ain't right. Something ain't right. Did I write it down wrong? 2 root 3 over 3. So secant of an angle has to be 2 root 3 over 3. 1 over cosine has to be 2 root 3 over 3. Multiply both sides by 3. And multiply both sides by cosine. Divide. 3 divided by 2 root 3. Multiply top and bottom by root 3. You get 3 root 3 over 6. Oh, Robert. It's Friday. I'm so looking forward to the weekend. I'm just being stupid. That's 2 down here, they reduce. This is root 3 over 2, is cosine theta. So this is saying where on the unit circle is the x-coordinate root 3, but you can't be down here. You have to be between 0 and pi. So where is the x-coordinate root 3 over 2, and that's here, and that is pi over 6. Jeez. I think that's a sign that I'm done. All right, 3 more to go. All right. Oh, wait, these are calculators. Yay. I don't have to do these. Okay. So get your calculator out and see if you have these functions. I'm not going to test you on these calculator problems, but just to make sure you can do them. Secant inverse of 4 is 1.32. That's number 45. Number 47, cotangent inverse of 2 is 0.46. And 53, cosecant inverse of negative 3 over 2 is negative 0.73. And that is it. Hope that helps. I'm trying to keep up. Try.